So the first example that we have here, we're going to go ahead and write it down. F of x, f of x is equal to 2x cubed minus 5x squared plus 4 to the fifth power. So that is our first example here for the chain rule. Okay, so the chain rule, if we go ahead and write the rule down over here, it looks like this. We're given a function and it has another function inside of it. So function of a function. And when we use the chain rule, basically what we're doing is we're keeping the outer function, we are deriving the outer function. We're keeping the inner function the same, okay? And then we're gonna go ahead and take the derivative of the inner function. So again, let's do this example and see what that looks like. So we're going to remember, we're keeping the inner function the same. So we're going to have 2x cubed, let me erase that, 2x cubed minus 5x squared plus 4. And the outer function here would be deriving that power 5. So we're going to have, it's kind of like, this example is kind of like taking the derivative of, let's just say, x to the fifth power. So we know that that's going to be 5x to the fourth. So this is x is the inner function, essentially. So that's going to be 5 times 2x cubed minus 5x squared plus 4 to the fourth power. And then we're going to have to take the derivative of the inner function. So let me erase this. Well, I'll keep the rule here. I should have done this a little bit down over here, but let me just slightly write it down here. I'm going to write it with the d over dx of 2x cubed minus 5x squared plus 4. All right, now all we have to do is derive that. So we're going to rewrite the 2x cubed minus 5x squared plus 4 to the fourth power. And we derive each term here. So that's going to be 6x squared. And this is still going to be minus. So we're going to put a minus sign there. I'm going to go ahead and put parentheses as well. And that's going to be negative 10x squared, or minus 10x, or 10x. That's it. And then plus 4, when you derive a constant, it is just 0. So this is what we're left with. And this is our final answer. All right, let's take a look at our second example here. We have f of x is equal to x to the fifth power plus 3x squared minus x to the 50th power. Now, I would pause this video and see if you could try to solve it on your own, and I'll be back. All right, so let's see if you got it correct. So the first thing is to take the derivative of the outer function. So that's going to just be 50 times x to the fifth. This is the inner function here. So x to the fifth plus 3x squared minus x. And then this will be 49. And then we take the derivative of the inner function, which is x to the fifth plus 3x squared minus x. So we're going to go ahead and rewrite that left side over here as 50 x to the fifth plus 3x squared minus x to the 49th power. And then multiply, we're going to put parentheses here. That's going to be 5x to the fourth plus 6x minus 1. And that is our final answer. So if you got it correct, you're on the roll here. All right, let's take a look at our third example. Our third example is going to be f of x is equal to the root of 5x plus 1. And this one is really easy. So the square root can also be rewritten to a power, and that power is half. So let's rewrite this function as f of x is equal to 5x plus 1 to the power of half. Okay? And now we can easily use the chain rule here. And we'll take the derivative of the outer function first. So that will be multiplying the half to the outside here. We're going to keep the inner function the same. And this is just half minus 1, which is negative half. And then we take the derivative of the inner function, which is 5x plus 1. And of course, we take the derivative of those two terms there, 5x and 1, and we just get 5. So we have half 5x plus 1 to the negative 1/2 power times 5. Or sometimes you could go ahead and shift that 5 over to the left side and have 5 over 2, 5x plus 1 to the negative half. Or you can also rewrite the negative exponent as you could bring that over to the bottom. So you could have 2 times 5x plus 1 to the power of half, and then 5 above. Or you could extend it. Sometimes professors don't like to have square roots at the bottom, so you could rewrite that as a square root, and then you're going to have to multiply that root again on the top and bottom. But these are basically the answers as well. So you can have these three or a bunch of other ones as well. Let's go ahead and take a look at our final example for this video. So we're going to have f of x is equal to 3, or we're going to have this as the denominator. I rewrite the denominator first because it's longer here. So we're going to have the cube root of x squared minus 1, and right below the 1. So this one's not confusing at all. This one you could use quotient rule, but you don't have to. What you could do is rewrite that radical symbol there as not half this time, but 1 over 3. So we're going to have f of x is equal to, I'm going to rewrite the bottom as x squared minus 1 to the power of 1 over 3. Okay, and then right below that 1. And now we can rewrite it with a negative exponent. So f of x is equal to, and again, you could use quotient rule if you want, but that's a longer version. We're going to have x squared minus 1 to the power of negative 1 over 3. And now you could use chain rule. So take the derivative of the outer function, and we're going to have negative 1 over 3. X squared, of course, the inner function stays the same, to the power, so negative 1/3 minus 1. You need to have the same denominators, and they're going to be negative 4 over 3. All right, so negative 4 over 3. And then we take the derivative of the inner function, which is just going to be the derivative of x squared minus 1, which is just 2x. Okay, so that could be your final answer. I'm not going to rewrite the other ones, but if you want, and depending on how your professor wants it, then you go ahead. But it's just going to be, for me, negative 1/3 times x squared minus 1 to the power of negative 4 over 3 times 2x. And of course, I could just rewrite this 2x over here on the left side if I want. But I'm going to leave it like this. Hope you guys enjoy the video. We're going to have more chain rule videos coming up. After this chain rule, we're going to go ahead and move into, let's see, I'm looking at the book here, and it says that we get into implicit differentiation. But I'm going to go ahead and check our GRE. Yes, the GRE actually does go over implicit differentiation. So we're going to have to go over that chapter. So it's going to be, I don't know, in the coming days, I'm going to go over the implicit differentiation. But for right now, until the end of the weekend, we're going to go ahead and finish up with the chain rule. The next video is also going to be chain rule, of course, but it's going to involve trigonometric functions. So I hope you guys enjoyed. Subscribe to my channel to see more. Please give this video a like, and I'll see you guys on the next one.